So today we are going to solve this problem, last stones weight to 1049. So in this problem you are given some stones of array, and each stones has a weight, like stones 2 has stone, this is 2 stones weight is 2 and this stone weight is 7. Okay, so you can pick any two stones and smash them together. Smash rule says that if you smash stone x and y, if x and y have same weight, so both stones will disappear. Okay, if different weight, new stones so it's become new stone is x minus y was absolute difference. Okay, so our goal is, after smashing stones again and again, only one stone may remains on 0. So you must find the minimum possible final stone. Means smash in such a smart way so the last remaining stone weight is as small as possible. So if we have array stones of array like this, 0 and stones is about 2, 7, 4, 1, 8 and 1. Okay, one smashing order, we take 8 minus 7 is 1, 8 minus 7 is 1, and 4 and 2 is 2, 2 and 1 is 1, 1 and 1 is 0. So the final stone is 1, so output is 1. Okay, let's take another example. If we have stones array like this, 1 and 2, so 2 and 1 is 1, 2 minus 1 is 1, and so the final stone is 1, the output is 1. Okay, if we have stones array like this, 3 and 3, so there is no stone left, so the output is 0. So we can try, so we are trying to smash the stones in a smart order, so leftover the weight becomes minimum possible. Okay, so see, when we smash stones again and again, the final result become, some group 1 minus some group 2. Okay, means we are actually dividing stones into two groups, group A and group B. So goal, make both sum as equal as possible. So difference small, last stone small. Okay, difference 0 is no stones left, so difference always positive. If 10 minus 6 is 4 and else 6 minus 10 is negative 4, so weight cannot be negative, so we use ABS, sum 1 minus sum 2. So see, instead of smashing, we think choose some stones, remaining stones automatically go to the other group, so we only try find subset sum whose sum is equal to total divided by 2. So see, in recursion how can we solve? We I and current sum. Okay, I means which stones we are on, and current sum means current chosen group. So take stone or skip stone, we have two choices. If we have array like this, stones of array like this 2 and 3, and total is 5 and target is 2. If we have the, okay, so see, 0, 0, if we skip 1, 0, if we take 1, 2. Okay, if we skip, we have two options, 2, 0, and if we take 2 and 3. If we skip, just take 2. If we skip, no, that's why they not give anything, so it was 0. So so we check valid sum is less than target. Okay, 2. So see, 0 and 2 is best sum. Okay, 0 and 2 is best sum because it was an index, it is index. Okay, 0 and 2. So best sum is 2. So the final answer is total minus 2 into best sum. So 5 minus 2 is 1. 5 minus 4, okay, 5 minus 4 is 1. Let's solve in another example. If we have stones like this, 1 2 3, and total is 6 and target is 3. Okay, see, 0 comma 0, this is index. If we skip comma 0, if they have two options, 2 index 2 and if the value is 0, index 2 the value is 2. If we skip index 3 is 0, and if we take 3 comma 3, this also have two choice. If we skip, if we take, and next here 1 comma 1 index, and if we skip 2 comma 1, and if we take 2 comma 3, okay, 0 1 2 3 is best. Okay, 3 is best. So the best sum is 3. So 6 minus 2 into 3 is 0. Okay, if we have stones, see, we have stones 2 3 now. If we have stones, the stones 2 and 3, total is 5 and target is 2. So find maximum subset, sum is less than 2. So what is one word? When we do recursion, we think what change in every call. One is index change and next is current sum change. Okay, so one state is I and current sum. So see, 0 comma 0, 1 comma 2 and 2 comma 0. So first line must store these values. Okay, so like from the code we make, so in solve int I in current sum in target, and we call this see. Next we have taken this example now, 2 3 bit. Let's make a tree of this 0 comma 0. If we skip 1 comma 0, if we take 1 comma 2, we take 2. Next we have two options. If we skip 2, 0 only. Same if we take 2 comma 3, because it was invalid. If we skip, yes, that's all, it gives us 0 only. Okay, see, leaf nodes return 0 and 2. Okay, if nodes become 0 and 2. So when recursion stop, okay, when recursion stop, when no stones left. Okay, so that means I is equal to stone dot size. So we return current sum. Base case, this was a base case. Let's write down the base case. Next is base case. If I is equal to stone dot size, we just return current sum. So okay, next where was my time? Okay, see, node 2 comma 0 is written 0. Okay, it's written 0. 2 comma 2, it's written 2. Can I take stone? Rule was current sum place stone of I is less than target. So 1 and 2, stone is 3, so 3 plus 2 plus 2, so 2 plus 3 is 5 is greater than 2. So take was not allowed, so first we create a variable. It is in take is 0. So why 0? Because maybe take was not possible. So no, see, if take was not possible, so that's what we do. Let's write. First we create variable of take. In take is equal to 0 if current sum place stones of I is less than or equal to target. Take is equal to solve of I plus 1 current sum place stone of I target and stones. Okay. See, if current sum place stone of I is less than or equal to target, so means we create a branch only if valid, no actual code A. So it was an actual code. So see, if we have 0 comma 0 take 2, so 1 comma 2. Okay, next we want to create a skip. If I ignore this stone, so 0 comma 0, if we skip, it's become 1 comma 0. Okay, so write a code of skip. In skip is equal to solve of I plus 1 current sum target and stones. Some same index moves. Okay, so what to return? Maximum sum possible, so we choose best branch, so we just choose best, return max, take or skip. Take skip. Okay, next see, we return take or skip. So skip result is 0 and take result is 2. Okay, see, skip result is 0 and take result is 2, so the max answer is 2. That's solve. So now we just write down the code. We just complete this. We make int total is equal to 0 for x is stones or equal to x, and target is equal to total divided by 2, and best sum equal to solve of 0 and target stones. Now we just return total minus 2 into best sum. That's all. It's anything wrong if current sum stones. We have just written stone. It is sort into 0 if what it was taking stones, stones. Yes. See, it worked because recursion was not good. So why we cannot use recursion? Okay, so we have stone this only. Let's take this example. If we have stones is equal to 2, 3 and 4 and target is 4, so 3 becomes 0, 0, 1, 0 and 2, 0 and 2, 3. If we take 1, 2 and 2, 2 and 2, 5. So see, same states come again and again, like same states has come again and again, 2, 0 and 2, 2. So same calculation is many times. So its time, the time of this is 2 to the power n. N is equal to 100. So 2 to the power n is called impossible. So recursion is too slow and TLE, so stack overflow and risks. That is the reason we do not use pure recursion. So now we use memoization top-down DP. If I already solve a state, why solve again? Why we solve these states again? That's all. So we store answer. So we store the answer. Key is I, current sum and value is answer. Okay. So 2, 0 is 0 and 2, 2 is become 2. So directly return from map. So how map works? Before solving, we check in map. If exit, we return stored answer. After solving, we store the answer. Okay. So let's write the code. Let's convert this code in map. First, we create a map. Map, string and int memo. This memo. So now we just make a string key. String key is equal to string I plus to string current sum Next, if it already is stored in map, if memo dot count of key is already in map, so return from here, return memo of key, so we take the option, we store the answer where is key, and in skip where is the answer, which is return memo of key is equal to max. See, so only three things we have added. First is map, and next is we create a key of I and current sum. Before we solve, we check in here. Okay, so why this is fast? Yes, because it was same state solve, not we same state we are not solving again and again. See, so why we cannot use memo? So why is memo is not always best? In I and current sum, range can be big. Okay, so current sum total is divided by 2, so memo the n into targets, and map is extra heavy because string key, hashing cost, and extra RAM. Okay, in Leetcode, see in this program the constant is big, so map of memo can become slow, plus memory is heavy. So for this we are going to solve in tabulation. We direct access the array, so no recursion, no stack, no hashing. Okay, in simple, see, recursion state was I and current sum. Okay, means using first I stone can we make sum is equal to s, so we can convert into dp table. Dp of yes, can we make sum, boolean dp is enough. So the first stage, final total, if we have stones like this 2, 7, 4, 1, 8 and 1, so the total of this is 224, total is 23, and target total divided by 2, total divided by 2 is equal to 11. So we try reach sum close to level. Okay, so idea is we want minimum last stone weight is that split stone into two groups such that their sum is different is minimum. So the state is sum of the stone in group 1 and target is total 2 because the best close to half total minimized. Okay, so let's take an example. If we have stones like this 1, 3, 2, 1 minute. So if we have stones like this 1, 2, 3 and total is 6, so the target is 3. So the target is 3, so we want to find the subset. Sum is less than 3, not 2, less than 3. Okay, so maximum sum. So first we create dp array in tabulation. Dp of yes true if we can make sum yes using some stone. Okay, see dp of 0 comma is 3 and it's look like true, false, false, false. So 0 sum is always possible. Okay, 0 sum is always possible. See, first we create DP array, okay, in tabulation. First we understand. See, DP of yes, can we make some yes. DP of 0 means true, empty subset, okay. So see, if we have example 1 2 3 only, so DP array size is DP of array size is size plus 1 target, so the size become 4. So we create for DP of 0 and DP of 1, DP of 2, DP of 3. So initially only sum 0 possible, so DP of 0 is true, okay, it was true. So DP become true, false, false, false. So means DP of sum is true. Some yes can be made by some subset of stone, and DP of yes is false, so some yes cannot be made yet. So first we take first stone. Let's take first stone. See, DP of yes is equal to DP of yes or DP of yes minus stones. So start yes target is stone, so stone is 3 1 3 2 1. We go to backward, okay, 3 2 1. See, just a second, 3 2 1. So stone 3, DP of 3 is equal to DP of 3, or DP of 3 minus 1 is equal to DP of 3, or DP of 2 is false or false is false, okay. Some stone 2, DP of 2 is DP of 2, or DP of 2 minus 1, or DP of 1 is false or false, so it's become false only. So stone 1, DP of 1 is DP of 1, DP of 1 minus 1, or DP of 0. So false and true, so it's become true. So array update, so DP array will update like this. So DP array update like this: T F false false and T, okay. So sum 1 possible by taking stone 1, sum 2 or 3 was not possible yet, okay. So that's how we can solve this, okay. We cannot write full code now. Let's write down the code in DP. First what we do, first we comment out all of this, okay. Command C. First we comment out all of this, and next we first we create total sum in total is equal to 0 for x is to s stones total is all equal to x, okay. Next, target divided by total in target is equal to total divided by 2, okay. Next step, we create a DP array. We insert vector boolean for DP of target plus 1, and we fill all of this with false, okay. So DP of 0 is true, DP of 0 is true. So next loop, go through the stones for int stone is to stones. Store in stones for int s is equal to target and s is less than or equal to stone and s minus minus. We're going to the backward. Okay, so dp of s is equal to dp of s stone or dp of s minus stone so find best sum who was less than target. Okay, int best sum is equal to 0 for int s is equal to target or s is less than or equal to 0 s minus. So if dp of s best sum is equal to s, so break break j and just return the final answer. Return total minus 2 into best sum. Okay, see it was 1 or not. What happened? Yes, see, so dp of 0 is true, empty sum. For each stone check backward, update dp of s. So we are going to update dp of s, and after all stone find the maximum sum. Target sum is less than target and complete final last stone weight. That's all. So see, that's all. See, now see, just complete this. Take first stone. We take first stone. dp of s or dp of s minus stone. Okay, so the start target we have done this now take stone 2. We take stone 2, we have done this state. So we loop start 3 to see loop start from 3 last. dp of 3 is dp of 3 or dp of 3 minus 2 false. So or dp of 1 is equal to f or t is equal to true. Okay, next state 2, dp of 2 or dp of 2 minus 2 is false, and or dp of 0 is equal to false or true. So it was true, so dp array will update and it's become true false true. Okay, see, now sum 2 possible by taking 2 stones. So sum 3 possible by combination 1 plus 2. Okay, 1 plus 2, it was 3, not was third stone 3. let's take a task stone. Loop start from 3 to 3 only. So dp of 3 is dp of 3, or dp of 3 minus 3 is equal to true. So our dp of 0 is t or t is true. Now dp earlier become true. Okay, so sum 3 possible by 1 plus 2 or just 3. So all sum is less than target can be met. So dp of C, formula is of C, dp of yes and or dp of stone yes minus stone, can I make some? Yes, no. So either I could already make it before, so dp of yes, or I can make it by adding current stone by to previous sum. So that was dp of yes minus stones. Okay, always loop backward, so avoid counting same stone multiple times. So finally the largest sum is great less than target, so that is true. So it was a best subset sum. Okay, that's all.